Hello everyone, welcome to my YouTube channel. So here today we are going to be looking at mathematical induction, the divisibility type. So this one involves division. Is a number divisible? So we have the question says, use mathematical induction to prove that the statement is true for all integers n. So the first one we are going to have is, so we have our 4n minus 1. 4 to the power n minus 1 is divisible by 3. So is the number divisible by 3? So what are some of the things you have to do? So the first step that you are going to take is the basic step. So the basic step gives you more like you're just going to have, under the basic step, you're going to take a number such as n is equal to 1 and see whether or not it is divisible by 3. So what are we going to have? We are going to have 4 to the power 1 minus 1 will give us 4 to the power 1 is 4 minus 1, which will give us 3. So 3 is divisible by, is divisible by 3. So that means to say you can divide. We are going to say for any number, as long as you put, even if you were to put n is equal to 2 here, it will give you 4 to the power 2 minus 1, which will be equal to, you have 4 to the power 2 is 16 minus 1, which will give you 15. So 15 is the number that we have. Now, if we are having that as our number, which is our 15, that simply means to say 15 is still divisible by 3. So after you do that, any number, it is going to work. Now you don't know, you cannot just keep trying. You put your n is equal to 10, n is equal to 11. You need mathematical induction. So what are you going to do? So after you know the basic one is true, you are going to say it is true for n is equal to 1. So that means to say the next step you're going to take is the inductive step. Now, what does the inductive step? You are going to assume that it is true for n is equal to any value of n, which we can call k. Why use k? K because k could represent any number. It could be n is equal to 2, n is equal to 3, n is equal to 4. So we are going to assume that it is true for n is equal to k. Now, what does this mean? We are going to get our equation, which is this one. If we get this equation, where there is n, we are going to put k. Now, what we are going to do is that let's assume that it is true that for n is equal to k, we are going to find the value. So what this means is we are going to say for where there is n, we are going to say k minus 1 should be equal to. Now, we are going to say 3x. Why put this? So a simple example is this. If you are looking at, let's say 4x like this. So 4 is equal to 8. Why is 4 equal to 8? This is true if you have your 4 like that times your 2. 2 times 4 is equal to 8. That's how come. That means to say x represents 2. Then we have our 4 like that. So as long as we have any number like this, it means to say when we put our minus 1, then we are going to say should be equal to that number that we are saying that it is divisible by x. It doesn't matter what number this is. Like for another example that we can have, if you look at 7, let's say 7x is equal to 28. Why is 7x equal to 28? So 28 is the same as 7 times 4. Then you have your 7, you have your x. So this x is equal to this 4, this 7 is this one. So that's the meaning of doing that. Completing the statement, assume that it is true for n is equal to k. So we are going to complete it by saying that is there exists the integer x such that, so this is the integer. So 3 represents that this number is equal to 3 as long as you multiply an integer x, I've explained. So with that said, after you do that, we are now going to say we need to show that it is also true for n is equal to k plus 1. Now, how we are going to show that it is equal to n is equal to k plus 1, we need to have a 3 times something. It doesn't matter, it could be x plus 1, but as long as we have a 3. So any number when you have something like this, as long as you have something like this, it means to say this number is divisible by 3. Like for example, you can have your 9. Okay, let's say if you have your 15 like that, 15 is equal to, you are going to find that 15 is the same as having your 4 plus your 1. 4 plus 1 is 5 times 3, that's 15 still. So that means to say, now what if here we have x? It still doesn't change anything. So that means to say that as long as we have such a situation, it means to say it is divisible. So with that said, we are going to take our 4. So taking this, so this is the inductive hypothesis, where you set your n is equal to k plus 1. So this 4 to the power, you have your, you are going to take this one. When you take this one, then what you are going to get is, you are going to take this value this side. 4, it will be 4k, should be equal to 3x plus 1 like that. Now remember, you need your n to be equal to k plus 1. So how do you add anything to k? How do you add plus 1 here? So you are not going to substitute, but you are going to multiply. So if whatever number is here, if it is 4, multiply by 4. So you are going now to multiply by 4. So if you multiply by 4, this will give you a value 4 times 4. So 4 is multiplying everything. So 4 times your 4 times the to the power k should be equal to this 4 multiplies this. We are going to have 4 times, so this dot means times, we have our 3x plus 4 times 1, it is a 4 like that. So as you can see, according to the rules of indices, when you multiply, you are going to pick one base. So 4 is common, then add the powers, which will be 1 plus k, but let's just begin with k plus 1. So take one base, add the powers, that's how we multiply. So 4 to the power 1 times 4 to the power k is this, should be equal to, now here you need a 3. So what are you going to do? You're going to say this is the same as 4 times 3x. Now you know that 4 is equal to 3 plus 1. So we just want a 3. Then if you have the 3, take this value this side. So this gives you 4 to the power of k plus 1 minus 1 should be equal to 4 times our 3x plus our 3 like that. Then from here, factorize, 3 is common, so we are going to say 3. Open brackets, we have our 4, then 4, we are remaining with x plus this. If we remove 3, it is 3 divided by 3 is 1. So this is what we have. We have 4 to the power k plus 1 minus our 1 like that. So as you can see, we have a 3 here. So you can just say that, hence these statements are very important. We just don't write. Hence the 4k plus 1 minus 1 is also divisible by 3, because it is equal to 3 times some integer like that. So that is how we deal with that. Let's look at our next problem. The next one, it says that your 3n minus 1 is divisible. So we are proving, use the mathematical induction to prove each statement is true for all integer n. So we have 3 to the power n minus 1. If it is divisible, be divisible by 2. So we are going to say the inductive step, the basic, we begin with the basic step. So the basic step, we are going to set our n to be equal to 1, which will give us, we have our 3, where n is, we have 1 minus 1. This is giving us a value of 2, which is divisible by the number they have given us, by 2. So we can say that it is true for n is equal to 1. From there, you are going to go to the inductive step. So the inductive step, you are going to set your n. So we are going to say assume. So these statements are very important. Assume that it is true for n is equal to k. That is, there exists an integer k. There exists an integer x, like that. So that means to say we are going to grab our equation, which is our 3n, minus 1. When we grab this equation, we are going to say 3. Then where there is, we are saying n is equal to k. So we are saying 3 to the power k minus 1 should be equal to, which number is it divisible by? This number is equal to 2 times some integer x. Remember where we are getting this. It is because it worked for n is equal to 1. N is equal to 1 worked. So if we assume that it is also true for n is equal to k, that means to say whatever the value will be here, it will be equal to a 2 times x, just as I have explained. So with that said, after that, we now need to show that it is true for n is equal to k plus 1. So using the inductive hypothesis. So the inductive hypothesis, you are going to get this equation and say, so we have 3 to the power k, then we have minus 1 should be equal to 2 times x. So this 3 is common. So what are we going to do? So we are going, since we want this one, this was the one that replaced n, we want plus 1, so we are going to multiply by 3, since the 3 is the power there, or should I say the base. So this 3 times this 3, so we are going to have 3 times, so this 3 is multiplying everything, 3 times 3 to the power k plus minus 3 times 1, it will be equal to, we are going to have 3, should be equal to 3 times this, we are going to have something like our 2. So we have our 3 times our 2x, like that. So this was supposed to be taken this side, so we are going to take it there. So we have our 3 times our 3 to the power k should be equal to 3 times 2 to the power x. Then we have plus our 3, like that. After doing that, 2 is the one that is divisible, so we need to make this into a 2. So we are going to say 3 dot 2x, then we have plus our 2 plus 1, this is 3. So we have this side, take one base, adds the powers, so we have k plus 1, like that. So this gives us, we have 1, take it the other side, so we have 3 to the power k plus 1, then we have minus 1, if this is taken this side, should be equal to 3 dot 2x, then we have plus our 2, like that. So with this said, we have our 2 is common here, so we are going to take 2, we are remaining with our 3x plus our 1, like that. Then we have our 3k plus 1, then we have minus 1, like that. So with this done, what are we going to have? So as you can see, it is true. So we are going to say this 2 is representing that it is divisible. We are going to say hence, for hence the 3 to the power k plus 1 minus 1 is also divisible by 3. So you can just say hence proved. The last question that we are going to look at is we have this one, which is our 9 to the power n minus 1 is divisible by 4. So we are going to take this, and when we take it, okay, yeah. So when we take this, so no difference. So we are going to begin with our basic step. We are going to let our n be equal to 1. Replace, we have 9 to the power 1 minus 1 should be equal to 9 minus 1, which is equal to 8. Then what we are going to have is, since that is what we have, we are going to get our value, which will be equal to which is divisible. We can say is divisible. Let me just move this. We can say is divisible by 4. So 8 is divisible by 4. So as you can see, you can divide 8 divided by 4, since they want us to know that. Then we are going to take the inductive step. So under the inductive step, we are going to set our n. We are going to assume that it is true for n is equal to k. That means the equation, which was like 9n minus 1, we are going to have our 9, then our n is k minus 1, like that, should be equal to. So we are going to say that is there exists an integer x. So we have, this should be equal to 4. 4 is divisible, so that means we have our 4x like that. So after doing that, we are going to take the inductive hypothesis. So under the inductive hypothesis, we are going to set our n. We want to show that it is true for n is equal to k plus 1. So how do we do that? We take this. So by taking this, we are going to have a value that is equivalent to, we have our 9 to the power k minus 1 should be equal to 4x. So this we are going to multiply by what? So 9 is the one that is attached to the k. So before we multiply, let's take the one the other side. So we are going to have our 9 to the power k should be equal to 4x. Then this one we are going to have plus 1. So we multiply this, let this multiply by 9, so that we add 1 there. So 9 times 9, it will be, we have 9 times our 9 to the power k should be equal to 9 times 4k, it will be 4x like that, plus 9 times 1, it will be a 9 like that. So we take one base, adds the powers, should be equal to, we have our 9 like that, dot 4x like that. Then we know we want 4 to be outside, so 4 can enter into 8, so we are going to have 8 plus 1. So the 1 goes back this side, so we are going to have 9 to the power k plus 1 minus 1 should be equal to 9 by 4x. Then we have plus our 8 like that. So with that said, what are we going to have? We are going to have our 9 to the power of k plus 1. Then we have minus 1 should be equal to 4 is common here. So we are going to say 4 is common. Open brackets. We are going to remain with 9 since we have taken the 4x like that. 8 divided by 4 is 2. So we have plus our 2 like that. So we can say that 9k plus 1 minus 1 is also divisible by 4. So we can say hence shown. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.